Welcome to Ask and Learn.
So now we'll work on problem 8 from chapter 6. In this problem, we're told to consider a fictitious one-dimensional system with one electron. The wave function for the electron drawn below is psi x is equal to sine x, from x is equal to 0 to x is equal to 2 pi. So we can go ahead and reproduce this wave function. We have 0, pi, and 2 pi. And the function looks something like this. And so part A asks us to consider or to sketch the probability density, which is psi squared x, from over the same range or domain. So in the probability density, which is equal to psi squared x, will simply look like the sine function, but it will be positive in all areas. So instead of decreasing when it reaches pi, it'll stay positive and go provide the mirror image from pi to 2 pi. So that is a sketch of the probability density. And then part B asks us at what value or values of x will there be the greatest probability of finding the electron? So the greatest probability of finding the electron is going to be the point at which the probability density is the highest. And we can see that there are two maximum in this function, which corresponds to pi over 2 and 3 pi over 2. So those are the two most probable locations for the electron. And then in part C, we're asked at what point is the probability, what is the probability that the electron will be found at x is equal to pi, and what is this point called? So we're looking at the probability at this point here, and we can see that the function is equal to 0, so that's 0 probability that it will be found at that point. And when we have a point like this on a graph, on a wave function, it's called a node.